In this section, we will be working with scientific notation. Now, scientific notation is a way that mathematicians or scientists easily handle very large or very small numbers. Now, at the top of the page, I included a table that shows the powers of 10. Beginning with 10 to the fourth is 10,000, 10 cubed is 1,000, and so forth. Moving down to 10 to the 0 is 1. Then with the negative exponents, you have 1/10 or 0.1, 1/100th or 0.01, and so forth. And that's the starting point for scientific notation, understanding the powers of 10. Now on the right, we have a table that shows a number written in scientific notation, and I wrote some examples of these at the top of my page here. I did not copy down the entire table. But the first one that you see is 3.21 times 10 to the fourth. In scientific notation, you will always have a number that is between 1 and 10. So here we have 3.21 times 10 raised to a power, in this case 10 to the fourth. Now essentially what you're doing is taking 3.21 times 10 to the fourth is 10,000. So 3.21 times 10,000 will give you 32,100. That's the main idea here. An easy way to go from scientific notation to standard form is to focus on the decimal point. Looking over here, this 32,100, the decimal point in scientific notation was between the 3 and the 2. So I'm going to imagine a decimal point right here. When you multiply it by 10 to the fourth, the exponent tells you how many spaces to move the decimal point. If the exponent is positive, that tells you to move the decimal point to the right this number of spaces. So here we have a positive 4. It tells us to take this decimal point and move it to the right 1, 2, 3, 4 spaces. This gives us the 32,100. Now going down to the bottom of the table, I pulled out the 3.21 times 10 to the negative 4. Again, starting with the number that is between 1 and 10. And then we have 10 raised to a power. Now this exponent is negative. If the exponent is negative, that tells us to move the decimal point to the left that many units. So 10 to the negative 4 would tell you to take the decimal point, which is here, and move it to the left 1, 2, 3, 4 spaces. All right, any empty space you'll fill in with zeros. And as you can see here, that is where we come up with this 0.000321. The decimal point was in between the 3 and the 2, moving 1, 2, 3, 4 spaces to the left. That gives you the number in standard form. So practicing this in example 1, we have 5.9 times 10 to the fifth. Starting with the 5.9. The exponent is positive. So that tells us we're going to move to the right 5 spaces. So starting here, 5.9, there's 1, 2, 3, 4, 5 spaces. Any empty space, fill in with zeros. All right, and then rewrite this nicely. This becomes 590,000 instead of the 5.9 times 10 to the fifth. The 590,000 is in standard form. Now part B another example, this time with a negative exponent. And again, you want to start with this number. So I'm just going to write the 8.3 down, giving myself some space. The negative 7 tells me to move my decimal point 7 spaces, this time to the left. So the decimal point was right here. Move it 1, 2, 3, 4, 5, 6, 7 spaces to the left. Fill in any empty space with zeros. So what you wind up with, 0 point, there's the decimal point, then 2, 3, 4, 5, 6 zeros. And there's your 8.3. This is the number written in standard form. Now in example 2, we're working the other way. You're given a number in standard form and you're asked to write it in scientific notation. So scientific notation, remember that number has to be between 1 and 10. So looking at the number that we're given 8,140,000. You want to take the number 8.14. We want the decimal point to be in between the 8 and the 1. So it was initially out here at the end. We want to see how many spaces we need to move in order to get it between the 8 and the 1. So we need to move 1, 2, 3, 4, 5, 6 spaces. So this is going to be 8.14 times 10 to the 6. In this next one, we have 0.000000091. So we want to take this decimal point and move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So in scientific notation, we will have 9.1 times 10 to the negative 9. In example 3, we're going to be doing some work on the calculator. So make sure you have your calculator out. You're asked to evaluate the following on your calculator. And when you do this, you will see something interesting occur on the screen. When you type in 850 raised to the 6th power, your calculator will give you 3.771495156. E, and then 17. This should be what you see on your calculator screen when you type this in. This piece right here, that is scientific notation. It's your calculator's way of giving the scientific notation. This E, this small capital E, 17, is the same as times 10 to the 17th power. It's just the calculator's way of writing scientific notation. So what you have here is this 3.771495156 times 10 to the 17th power. So this is going to be a very, very large number. So we want to start by just writing the number itself, 3.771495156. That's as much as the calculator can give you. Now the decimal point, you want to move it 17 spaces to the right. So it was here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then fill in the zeros. And insert your commas. And as you can see, this is an incredibly large number. And a similar thing will happen when you type in part B, 0.25 raised to the 8th power. Your calculator will give you 1.525887906. There's the E, negative 5. So this is the same as, let me copy down this number, 1.525878906 times 10 to the negative 5th So rewriting this in standard form, you're going to take this decimal point and move it to the left. Whenever you have a negative exponent in scientific notation, the number is going to be a very, very small one. So what this winds up being, just writing down 1, 5, 2, 5, 8, 7, 8, 9, 0, 6. The decimal point was in between the 1 and the 5. Moving it 1, 2, 3, 4, 5 spaces to the left. Now we have 0 point, filling in the empty spaces with zeros. And that is the number in standard